So, yesterday we discussed the basic introduction to algorithm. So, how we can solve a problem, what the problem solving is, and how it like kind of do. And then we did a little exercise to figure it out how we can solve a problem in a different ways, right? So, where we what we did, we just had the A to Z letters, and then someone predict a letter, and then others need to guess based on like whether based on indications, right. So, then there was a multiple ways multiple people doing. Some people was like kind of going half and half, and then some people going like random here and there. Okay. So, that is what we did. So, now the problem is when you have so we learn algorithm is so we have a problem and then steps to get the solution, right. We are trying to get the solution. Now, the problem is this: if you get the yesterday problem, different people approaching in different ways. So, that means when you get a one problem, you have multiple solutions, right. But now the big deal is how we can figure out which solution is the best one. Okay. For example, let us say I have a problem, right. So, I have someone create a solution 1. Okay. So, you create a solution 1, and the solution 1 take like 10 seconds to complete, right. It take 10 seconds to complete. Now, she create other solution 2. It takes 30 seconds to complete, right. But both giving the same results, same problem, same results, but different codes. Maybe someone use a for loop, another use a while loop, some no loop, recursive, whatever, is to give a different result. So, now obviously we like this solution, we like it. Why? Because it is fast, right. So, this is we call time complexity of algorithm, right. And now since it is run fast, probably it need 128 megabytes to run this solution, okay. And since this is going slow, this might only need 32 megabytes, right. So, if someone concern space, the storage it take, then this solution is the best. Why? It take less space, okay. So, now the problem is this: whether when we come up with the code, a solution, what is the time complexity and what is the space complexity, okay. So, which one we need to pick? It is very case by case. For example, if you are writing a program which run on a Mac or a something, then we can go with the time, because space is not a big deal, you have enough space, you can giving a space is not a big deal. But if you are writing a program to run on like a microcontroller or a ESP32 Arduino or something like that, then space also matters, because you have a very limited kilobyte size storage, right. So, then it matters. So, which one you pick is case by case. Let us say when some event happen, let us say a thermostat or something triggers some event, it is okay you respond in this within 2 minutes or something, but then time complexity does not matter, you need to focus on the space, right. But it is something you need to happen instantly, right. Let us say someone in a life support system, something is triggered, BP is dropping, it triggered, so then you need immediately alert, you cannot take 2 minutes to process, right. So, then time is matters. Now, when it comes, so nowadays on an algorithm, usually we do not measure space complexity, we always try to go with the time, right. Now, the problem is this, right. So, let us say this same program, this 30 minutes program, we are running on MacBook Pro, right? Okay, and the same program we take and run on some sort of a i3 machine, right? This is arguable, like for example, if this is not required much CPU and no matter what CPU it won't use, but for understanding, now time is different, time taking is different to the machine you are executing it. It is not always 30 seconds. And if you get a faster machine, you get a faster response, right? So seconds, the clock second is not a big valid measurement to measure whether it's a fast or slow, because it's depend on the horse. So what we do is usually we measure this with the number of, we can, for now let's say steps, right? The ideal word is operations, number of operations to give these results. So now you running on a MacBook or you running on a Windows or you running on a what, doesn't matter. Why? Because number of steps doesn't change, it's the same program, okay? So how we measure time complexity based on the number of steps. Now let's say you have an array, okay? My drawing line skill is very good. Right? So now this array has a different numbers, right? 2, 7, 3, 4, 6, 9, 8. Okay? So now let's assume you are going to looking for some particular number. Okay? You are going to looking for a particular number, right? So when you are looking for a particular number, the easiest way is you get a loop, for loop, and run through index 0 to other side. So then you can see whether this current index value is this. Okay? Now see this carefully. If you want to find number 2, that is the best case. Okay? Why? Because just as soon as you start the for loop, you find the number. If you find the number 8, that is a worst case, right? Because you need to run through the entire loop. Now this is 7 elements, but you think array with a million elements, you need to run through the n. Finding like a number 4 is a average, it's a medium. It is not too good, not too bad. So when you measure in this time complexity, we tell this is a omega. The best case is omega. There are so many misinterpretations. I have seen in interviews also, interviewer asking, what is the best BigO? An average BigO. There is nothing like that. There are 3 different notations to represent the best, average and the worst. Okay? So I have seen, even I saw a paper in one of the university saying, find the average BigO. You cannot do it. Okay? So now, if the average case, we represent with the theta, and the worst case, we referring with the O, right? Worst case refer with the O. So if you get any code, if you are finding a time complexity, right? When you find the O, the big O, we not call as a big O, is the one is the worst. Right? So why we go for the worst? Why we calculate the worst? Because then there is no, you cannot go beyond that. That's it, worst, right? So but if you find the best on a particular algorithm, and let's say 2% time it perform the best, 98% perform the worst, then it's wrong, right? So that is why we always finding BigO on the worst. So what you need to understand is there is nothing called best O or a medium O or a worst O. O is always worst. We find in the worst case. Okay? But if you are going for the big one, it's omega. If you are going for the average one, it's a theta. Right? So that is how we do it. So now, if you take a program something like this is not syntactically perfectly correct. Let I equal 0, I less than n, I plus plus, right. So, I am going to log I, log mean let us say print I, otherwise you use log, right. So, I am going to wrap this with a function, I am going to take a n as an argument. Okay. So, now if I pass 10 as the n, how many times this loop will run? 10 times, because it starts with a 0. If you give 100, it's 100 times. If you give a million, it's a million times. So, whatever the number you pass into the function, the program going to execute that number of time. Okay. So, we call this O n. Okay. We call this O n. Why? Because program is going to execute to the number of time we give. You need to see this. Let us say we graph this. Okay. The value and the operations. So, you will see it goes like this. Right. We have a different names for this, we can discuss this later. It goes like this, right. So, is this the best? We do not know yet. Is the worst? We do not know yet, but this is how it works. Okay. So, with the number of iterations, operations is determined by the number you are passing. So, the worst case is it go. Let us say you are looking for something, the worst case is the element can be at the end. I am going to add other for loop to this, for let j equal 0, j less than n, j plus plus, right, and then print j, right, and then again I am going to wrap this in a function, right, same. Okay. So, now let us say we pass 10, what going to happen? First one will print 1 to 10, okay, and second one will print again 1 to 10. So, then now what happened? Now what happened? So, say when we pass a number, the program executed twice as this number. You understand? Right. So, now if you build a formula for this one, you will see. So, this is what is this? O what? This one is O n. What is this one? O n. Right. So, now that means O n plus O n, which mean O n plus n, which mean O to n, right. So, this can be 2, 3, 4, 5, 6, 100, million, it can be anything, it depends on how you read in the program. But no matter what, this is what? This is a constant, it will not change. It can be 3, it can be 100, it can be million, but for the program it will not change, right. So, since this is a constant, we can forget about it, because since it's a constant you do not write it. So, this technique we call drop constant. When we write the complexity, we do not write the constants, we drop it, because there is no point writing it. Because so, now why? Because if you start to write the constant, this can be any, you have infinity number of permutations, right, 3 O3 n O4 n O5 n O6 n like that, right. So, therefore, we do not use the constant when you write in the notation, we drop it. So, we call this as a drop constant, right. There is other technique called drop non-dominant, this is a separate one, I'll explain separately, but this is called drop constant, right. When you write get the program, when you write these notations, don't ever write like this, you need to drop it. If you write like this in interview or somewhere, so that's meaning you have no idea what you're doing. Okay. So, we usually give an interview questions and calculate the time complexity. Some people I have seen writing like this, or 4n or something like that. That means you know little bit, right. And I am going to add other loop here. That means I am bringing that loop inside this, right. For let j equal 0, this is j, right, I equal 0, I less than n, I plus plus, right, and then I log j comma I, right. So, now if you run this program, what will print? Initially it will print 0, then when it come to this one, it will print 0, then it is going through this loop. Now, what will print? I is still 0, sorry, j is still 0, 1, 0, 2. Likewise, it will print up to 9, 9. Okay? It will print up to 9, 9. Understand, right? So, now tell me how many times this code execute based on the number you passing. Let us say you pass 10, how many time execute? 100. You pass 2, how many time execute? 4. You pass 5. Okay. So, that means this code will execute n squared, right, n times n. Why? This run n times, because this is how you determine, right. I took little shortcut. This is log n, right. So, this is log n. So, now this log n inside that log n. So, now it is not a plus anymore, right. Sorry, not log n, O n. Sorry, right. So, now this is inside. So, that means previously what we had, O n plus O n. So, now O n into O n, right. So, that means O, I do not have to write this, I am writing this because some people cannot process maths in head, right, n. So, that is what I write every step, right, O n squared, right, O n squared. Why? Because we are. So, now I am going to reserve this space to draw this chart, right. If we graph this one, let us say graph the previous one again, right. So, we will keep this without erasing, right. So, now if we graph the previous one we had like this, right. So, what is this? O n. Now, this one if you take, what happened when this goes, it goes is squared, right. I hope you understand these graphs, right. So, why? Because you can see when this number is even, when the number is even 2, this goes to 4, right. Even number is being 10, this goes here, right. So, this is right. This is nicely going like this, right, O n squared. So, now compared to these two, looking at the graph, which one is the best? O n squared, O n squared. Which one is the best in the time complexity? Yes, O n. So, usually O n squared generally considered as a most inefficient way you can write a code, right. So, now some people have, I have seen a written code, there are 3, 4, 5 loops inside, one loop inside other loop inside other loop. So, worst code you can write. So, what I am going to do is now I am going to write other for loop for let k equal 0, k less than n, k plus plus. So, when I say log here, this is not a logarithm, this is logging. Let me change this to print. Print k, right. So, now I am putting those through two brackets I erased. Okay. So, now let us do the math with me, see how it goes. Okay. So, now we know this block, what is the complexity? This particular loop, first loop, O n squared. So, after it run this, so that means this will run from, this one run from 0 0 to 0 9, sorry 9 9. Okay. After it complete that iteration, then what happened? Then it's going to run this, how many times? If n is 10, how many times? 10, right. So, that is what? That is what? Complexity, O n, right. That is O n, right. So, that means O n squared plus n, which means O n squared plus n. Okay. Now, here is the problem. See this one. Let us say n is 1000. Okay. N is 1000. So, now O, what is this value? N squared, n is 1000 now. How many zeros? 6 zeros, right, plus n is 1000. So, now you will see when it comes to the operation, when you compare to this is minuscule, this is negligible. Which one is dominant? This one is dominant. So, what we do is when we write this, we drop non-dominance, right. We do not write like this. What we write is still, even though algorithm is like this, we write this like O n squared. Why? Because if someone asks, let us say someone like you go for an interview, and then this type of algorithm come and ask to write the complexity, calculate the complexity, and you write like this, and someone asks why, or you can write saying why, because this is a concept called drop non-dominant. Okay. So, we are going to do some complex code and calculate the complexity. So, when you write it, make sure you are writing like this. If something is dominant, non-dominant coming, you drop it and write only the dominant part. Okay. So, when we go for code reviews, technically, right, especially not you, if you are like if you write a code, they will review it. When they write a code, SSCs are reviewing. When the SSC write code, tech leads are reviewing it, right. So, likewise, this is a code review from seniority, right. So, now what we go and see, if someone is write a code like O n squared, we are trying to see whether can we take it down to O n, or there are few we are going to discuss in a few minutes. So, can we drop down to that function, and again is take a n, right, and what it does is it return n into n, that is it, that is the function. Okay. It take a number and it return n into n. Okay. Now, how many operations, if I pass 10 here, how many operations this would do? 1. If I pass 100, if I pass million, 1. So, no matter what I pass, it is always doing same number of operations. So, this is we call O1. This is the best way of you can write a code, right. So, why if you see this one, right, if you see this one, so your line will go like this. Why? Because always it is 1, it is not going like this. This is my talent of drawing lines. Okay. It does not depend on what you do, but that being said, see this one. Now, if I pass 10, how many operations it would do? No. How many operations it do? Huh? How many? 3, because it is multiplied 3 times, right. So, now how many operations it do? 4. But if I pass 1000, it's still 4. Million, it's still 4. So, that now this will be O4 into 1, right. But what we do is we have a technique called what? Drop constant. So, we do not write that. So, your O notation does not determine by the number of operation it does, that keep in mind. Okay. We are not saying 1 because of it doing 1 operation, right. So, we are saying like now this time 4 operations, that means based on our previous formulas it is a 4 into 1, right. If it is a 10, 10 into 1, 100, 100 into 1, but problem is always this is a constant, this constant to the value you code you written here, that will not change. Okay. The code you written here will not change. So, this code is constant now, this number of operations constant. So, we drop the constant, that is the first concept we learned, right. So, drop constant. So, therefore, we are writing this is the best way you can write a code. So, now let us go some practical problem. In order for this to work, you need to have a sorted collection. Okay. So, let us say 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, this is what we did yesterday with the left right. Okay. So, now what I am going to do is I am going to search for a number. Okay. I am going to search for 1, right. I am going to search for 1, right. So, when I search for 1, what I can do is I can divide this in a half. And ask which side is the 1. Okay. Right. Do not think about the code now. See you are manually doing it. Which side is the 1? This side. Okay. And then I again divide half. Now, which side is? This side. Okay. And now again half. So, every time we divide in half. So, how many elements here? 8. How many divisions we made to figure out the number? 3, right. So, technically 8 we taken 3 times, right. So, that means we also have something like this, okay. 2 to the power 3 is 8, right. And now we can convert this to logs. How? Log 2 8 is 3, okay. Log 8, log 2, 8 is 3. Now, here is the I yesterday calculated this number and I wrote down, let me to write it, right. 429 496 7296. Okay. So, let us say we need to do the same exercise for an array which has this number of elements. Okay. So, now if you want to use this using a linear algorithm, which is a log n type of algorithm, how many iterations you need to run? How many? Huh? How many iterations you need to run? If you are, let us say you are looking for the last value. Huh? What do you mean this number? Read it. Okay, so that's 4 billion, 3 billion, 2 billion something, right? So, you need to run this number of iterations. Now, if you go with this technique, given this is sorted, from a billion, let us say this is the number of billion, in the first iteration we cut in half. Now, it is half a billion. Second iteration we cut in half. Believe me, you just need 32 iterations to find the number. Where if you go with a linear algorithm, you need to need this number. I do not know what the number is. This is 2 to the power 32. Okay. So, you will cite log 2, this particular number is 32. Okay. So, this technique we call this, when you write this, we write like O log n. Okay. O log n is going very close to this. You will see. Okay. So, now looking at this, you can tell the best way of writing a code, the most efficient time complexity is O1, and if you cannot do it, O log n, and if you cannot do that, O n, right. O n squared is kind of a territory you should not go, but we write it, but that is what it is. This technique called, we discussed this yesterday, divide and conquer. So, they have a thing, first 2 weeks exempted. Okay. So, now this is second week. So, from next week, every time they say sir, the 500 rupees fine for 2 weeks, right. So, after 2 weeks, when you say sir, 1000 per sir, and if you say Mr. or something, the half of that. So, the previous batch collected somewhere around 12,000, right? 20,000? Yeah. Okay, 18,000, most contributor was the Usman. So, now I feel like this time he will be the most contributors, I feel like that. So, then we went to a coffee shop and we had a coffee. I had to contribute more than the sir. Okay, so now apply your knowledge to this one. Take A and B as arguments. Okay. I have a for loop for let I equal 0, I less than A, I plus plus, print I. Okay. And I have for other for loop for let j equal 0, j less than b, j plus plus is j, print j. Okay. Right. So, now what you need to do is calculate the time complexity for this. Same. A plus B. Huh? Same. So why it is A plus B? Yeah. So why it is not? So technically, okay, let's say A replaced with N. Okay, let's say something like that. So now, so this is technically ON, right? So this is also technically ON, right? So that means O n plus n. So which means O to n, we drop the constant, then what is the ON? Why it is not this? Because what we learn is this type of for loop is categorized as ON, right? So this is again twice as this, just instead of n we are using A and B. So why you are saying this but not this? Yep.
It's because of the arguments we use, but when I realized, so the answer is not correct.
Okay. Jamsit?
I think, sir, value might change. We can give the A another value, B also we can give another value. But here n is constant, B will be one value. So
You? Why it is not ON?
I think A can be also changed.
Yeah, so that is the thing. So this will true as long as A and B is same. You call this function, let's say cal is the function name, 10, 10, then this is ON, right? If you calculate cal 100 and 100, this is okay. But the moment you change the different parameters, A is 10, B is 20, then different loops are operating in a different number of operations. So you can't say it's always n. So that is why we write like this. Okay? That is why we write this, because if you, let's say there's a condition, right? So A and B, take like this, there is something like this here, A equal B. Now what? Now it's ON. If someone asks given this and asking to convert this to ON, right? So usually in interviews do that. Be given this and asking convert to ON, right? So that is what. So this is an array, right? I want to, so if you get the index wise, array index start from 0, 1, 2, 3, 4, 5, right? I am going to add new element to this array. Now don't think this is not connected, this is connected, nah? So do I need to calculate the indexes, recalculate the indexes? No. So what is the complexity? Shankar, O1. Complexity is O1. Very good. Why? Because you are just adding, you are not shuffling the array. So now we are using the arrays. We do what we abuse the array, we do whatever to array we want, but you need to understand when you do this, this is what internally happening. So now you remove the last index. What is the complexity? O1, right? Adding O1, removing also O1. Now you add index, you add element in the front. Now do we need to recalculate the indexes? Yes. Harsha, what is the complexity? O log n. What is the complexity? On. What is the complexity? On. Jamsi? On. Where the O log n came from? Why? Because the moment you add to this becomes 0, you need to change every single index in the array. Everything happening linear to that side, same, okay? Cool. So now you remove the first element. Now what? Huh? Still ON. Right? Now you add an element. So this is the tricky. Understand properly. You add an element to here in the middle. Right? You are adding an element in the middle. So now you don't need to change this side, but you need to change this side. Now what is the complexity? Now what is the complexity?
Is it log n plus n?
Okay, good one. One answer, log n plus n. Okay. Any other answers? Huh? O n minus 2. Okay. N minus x. Okay. That's a very good one. So thinking where you are inserting. Okay. Cool. That's the best I heard so far.
n minus x.
Okay. Inspired by Shankar, sponsored by Shankar.
I think ON.
ON, okay. We add in the middle, huh? ON. Make one, okay. N minus x. Okay. So now we have various answers. Okay. So I'll tell a little story before you go with these two answers. Okay. There was a system we worked on. There was one engineer given the employee number. Employee number is a running number. Okay. What she has done, she's not engineer anymore, she's a PM now. What she has done, she get the count from the table, let's say assigned to x, and next ID is x plus 1. Perfectly fine, right? Let's say 50 records in the table. So now next one is a 51, next one is 52. This worked very well on the production until someone deleted the record from the database. Okay? Now there are 50 records in the database, last number is 50. Someone deleted 20th record. Now when you get the total, what is total? 49. Now plus 1, 50. 50 is already exist. There's a bug now. Do you know how she fixed it? What she did is, the fix is, she get the count and plus 2. So now 51. It worked until you need other record. Okay? What you guys forgot is one thing. O is what? Worst case. It doesn't matter where you injecting, you need to assume the worst case. Because if you get this, okay, there are two ways to solve this. If you get this, right, let's say half away you are injecting, half into n, right, but anyway we drop the constant, is end up with the ON. We drop the constant, no? Right, we don't use it, we don't use the constant, you drop the constant. You don't always carry this, what we learned, apply it, right. But even though you go with this theory, the two theory, right, that's how it is, you drop the constant. But what you need to understand is, you need to always assume the worst, because we are calculating the O. O is the worst. The worst is you add in this element to the first, or at least next to the one. Okay? So the answer is this. So there are few names for this. This graph we say loop in loop. Loop in loop is ON squared. If someone asks, okay, write a code to show loop in loop complexity, right? That's how usually when you go to interviews, especially these FANG interviews, right? So they don't straight away tell this. They don't say, okay, write a for loop to demonstrate ON squared. They will say loop in loop. Or sometimes they will say, write the proportional. Okay. So there are few names. Other two also have some names. I'll tell you. There is a website called BigOcheatsheet.com. Right, I got this example and everything from that. So BigOcheatsheet.com. So that give a nice graph to show where your code is fit and how to use and space complexity. So when you see that site, you will see why space complexities doesn't matter anymore. Okay. So this is, I remember that. So this is called divide and conquer. This is called constant graph, because one is always one. So first we are going to like this because these are very generic, right? And then we are going to talk about, when we talk about data structure, some data structures in Java and in JavaScript. Okay. Keep in mind, data structures is highly depending on, implementation is depending on language sometime. For example, if you get the Java, we implement the queue using linked list, right? That we have a queue interface, but we implement the queue using linked list, right? But if you get the Node.js, there is no there are data structures when you come to TypeScripts, right? But it's not strong as Java. If you go Python, there are different data structures, right? So data structures highly depending on the language you're using, but the common behaviors, right? Set, like for example, if you get the set, list, tree, those things stays common. So we are going to discuss that open area.